The title of this set of notes is Cramer's Rule, and you're going to learn how to calculate the determinant of a matrix, which you will then use in the formula for Cramer's Rule. And the reason that Cramer's Rule is particularly interesting is because we can use Cramer's Rule to solve for just a single variable. So instead of having to solve x, y, and z, we could just choose. What if we only wanted to know z? So we can actually save ourselves some work. Without finding x and y, we could find just z. This would be really helpful if we were writing a computer program and we had hundreds and hundreds of variables, and we don't want to wait for the computer to calculate all of those variables when we're looking for just one. Okay, so first thing we're going to start with is talking about the determinant. The determinant is a special number associated with a matrix. And all it does is it tells you whether or not the matrix has an inverse. So it determines if the inverse exists. So it's called the determinant. So the way you find a determinant, you're going to use a method that I call crisscross. So if you have a 2 by 2 matrix, I'm just going to call these values A, B, C, D. That should be C. A crisscross method, you would start at the top left. You go criss minus cross. And so as you're coming down the diagonal, you're going to multiply criss, so AD, minus, and then as you're coming down the cross, B times C. That will find you the determinant of a 2 by 2 matrix. But what if you have a 3 by 3 matrix? So A, B, C, D, E, F. I know the alphabet. D, E, F. G, H, and then I. Okay, so when you have a 3 by 3, what you're going to do is you're going to multiply the every entry in the first row by the determinant of what's called the minor matrix. So let's start with A. We can only use the criss minus cross pattern if we have a 2 by 2. So I'm going to ignore the column and the row that contains A. And what I'm left with is a minor matrix, E, F, H, I. And there I will do criss minus cross. So that will be EI minus FH. And that, I will multiply that by A because that's the entry in the first row. Then I'm going to repeat with B. I'm going to switch to black here for B. So now I'm going to look at B. And I'm going to ignore the column that B is in, and I'm going to ignore the row that B is in. So if you can see, what's not crossed out by black is D, F, G, I. That alphabet gets me every time. D, F, G, I. And that's where I will do criss minus cross. So for the second part, we have B times the determinant of the minor matrix, DI minus FG. So we've got one more entry in the top row, and that's C. We're going to ignore the row and ignore the column that C is in. And when we do that, we're left with the minor matrix DEGH. And with that minor matrix, you do criss minus cross. So the last piece is C times DE, DH, that alphabet, DH minus EG. The last piece of this is we have to now put the 3 pieces together. Do you see where it says remember to alternate the sign? So the first piece is positive, and then negative, and then positive. So you take the first piece, and then you subtract the second piece, and then you add the third piece. So you start with the first piece, subtract the second piece, add the third piece. So let's do an actual example here with numbers. Notice that this matrix doesn't have brackets, it has lines. It looks like the absolute value sign. That's a symbol for the determinant. You can also see determinant of matrix A, or you could see matrix A in the absolute value sign. That's a sign to you that you're doing the determinant. Okay, so let's start with that -2. -2 times, okay, ignore that column, ignore that row, and then with what's left over, crisp minus cross. So 5 times -1 minus 1 times 2. That's the first piece. Now the second piece, I'm going to erase this work so you can see the minor matrix more easily. Now we're going to work with the -1. Ignore that row, ignore that column, and we have crisp minus cross. So 4 times -1 minus 1 times 9. And then we'll do one more piece. Now we're going to work with the -7. Ignore that row, ignore that column. And with the minor matrix that's left over, crisp minus cross. So -7 times 4 times -2 minus 5 times 9. And then the last piece is putting these together. You're going to take the first piece as is. You're going to subtract the second piece and add the third piece. This is the setup for the calculation. Now at this point it's just simplifying. It's just a ton of arithmetic. Be really cautious with your signs. Work slowly. Don't be afraid to double check things with the calculator. So working from the inside out on all the parentheses. So here we have -5 minus 2, which is -7. And then that gets multiplied by -2. So the first piece is 14. And then we're going to subtract the second piece. And the second piece will be -4 minus 9, which is -13, times -1 is +13. Put the plus sign there just to remind me that it's positive, not necessary. You could have just written 13. Okay, then we're going to add the third piece. And in the parentheses we have -8 minus 45. Okay, so that's feeling a little bit big. So I might want to grab a calculator just to double check these numbers. So I should get that -8 minus 45 is -53. And then -53 times -7. Okay, so the product there is positive 371, because negative times negative is positive. So positive 371. Okay, so now we're going to put the three pieces together. So 14 minus 13, that's 1, plus 371 will be 372. So the determinant here is 372. The determinant of matrix A is 372. The number's not really meaningful to us yet. There is some significance there. It's not 0. So as long as it's not 0, your system has one solution. So we can tell right away that this system will have a solution. If you get 0 as your determinant, that tells you that your system is either inconsistent or dependent. So you have no idea if it has no solutions or infinitely many solutions, and there's no way to tell. Similar to the matrix algebra. If you have no if your determinant is 0, that will also imply that matrix A has no inverse. So just like in matrix algebra, you can't solve it. The only way to solve something to figure out if it's no solution or infinitely many is to use your Gaussian elimination or your Gauss-Jordan elimination. Okay, so how do you actually use Cramer's rule? So Cramer's rule uses 4 different determinants. You'll have the determinant of the matrix, and then you are going to have a determinant with the x's, with the y's, and with the z's. And I'm going to show you on the next slide how to do that. So you're going to set up your 4 determinants, and then you're going to calculate them. And you're going to solve for x, y, and z. And the way you solve for x, so going back to the beginning, Cramer's rule is used when you only want to solve for one variable. So if you want to solve for x, it will be the determinant of the x matrix over the whole determinant. If you want to solve for y, it would be the determinant of the y matrix over the whole determinant. If you want to solve for z, it will be the determinant of the z matrix over the determinant. This right here, that's the formula for Cramer's rule. So let's actually practice this. Okay, so we have this system here. So we're going to start by finding the determinant of the coefficient matrix. So we're not even going to use those numbers over there. We have 3, -2, 3, 5, 3, 8, and 1, 1, 3. Okay, so this will give us D, the regular matrix. So we need our determinant. So again, let's start with that 3 at the top. 3 times, and I'm ignoring this column and this row. And so I'm left with, let me do it underneath, I'm left with this minor matrix, 3, 8, 1, 3. And if I do criss minus cross, okay, then I'm going to go to the next value in the top row, which is -2. And ignoring the top row and the middle column, I'm left with 5, 8, 1, 3. So criss minus cross. And then lastly, I'm going to use the 3 in the top right corner. Ignore the top row, ignore the last column, and I'm left with 5, 3, 1, 1. So criss minus cross. And remember, I'm going to take the first value, I'm going to subtract the second value, and I'm going to add the third value. So go through and simplify all your values very carefully. This is 9 minus 8, which is 1. 1 times 3 is 3. And then in the red, I have 15 minus 8, which is 7, times -2 is -14. And then in blue, I have 5 minus 3, which is 2, times 3 is 6. And I'm going to take the first value as is, subtract, and add. So 3 minus -14, when you subtract a negative, it's like adding. So that's 17. Plus 6, that's 23. That's the determinant D. Okay. That one's required for all of the variables. You want to start with that. Now let's suppose I wanted to know what does x equal. So what I can do is I'm going to find the determinant of a special matrix. I want to move this down because I don't want it to go away. I need it there. Okay, so what I'm going to do is I'm going to take these 3 numbers that we started out ignoring. And the matrix we started with was 3, -2, 3, 5, 3, 8, 1, 1, 3. The column that represents x is the first column. So what we're going to do is we're going to actually change that column. And we're going to replace that column with the constants, -3, -2, and 1. And when we find the determinant of this matrix, that will be the determinant of what I'm calling the x matrix, because the x column has been replaced with the constants. And if you look back at the notes that we wrote, right here it says replace a column with constants on the right side of the equation. So these right side constants are replacing the x column right here. So now we're going to find the determinant of this x matrix. So starting with -3, ignoring that green column and the top row, Chris minus cross, and then going with the -2, ignoring that middle column, Chris minus cross, and then lastly that 3 in the top right corner, ignoring that last column, we're going to have Chris minus cross, and then alternating signs. Okay, so in blue here we have 9 minus 8, which is 1. So we have -3. In green we have -6 minus 8. That is -14 times -2 is +14. And then in red we have -2 minus 3, which is -5 times 3. That's 15. And then alternating, plus, minus, plus. Okay, so we have -3 minus +14. That's -17. Plus 15. That's -2. Okay, I need to backtrack for 1 second. I did make a mistake in the green section. So this is where I said be really careful with your arithmetic. We have -14. I forgot to multiply it by -2. So -14 times -2 is -28. Okay, so let's fix that. All right, so now we have -3 minus -28. Remember, subtracting a negative is like adding. So it's the same thing as saying plus 28. So that's 25. Okay, and then in the red, we have -5 times 3. That's supposed to be -15. Okay, so we have 25 plus -15 now, and that's 10. Okay. So the determinant of the x matrix is 10. So what is the solution for x? The solution for x is the determinant of the x matrix over the whole determinant, which is 10 over 23. So that is a solution for x. Likewise, we could do y and z. We're not going to do them completely here, but I'm going to show you how to set them up. I want you to try y and z. I'm going to show you how to set them up, and I'm going to give you the answer, and then see if you can get the same answer. Okay, so to set up the dy matrix, again, I'm going to move all of this. Okay, so to set up the dy matrix, you will replace the y column with the constants, -3, -2, 1. And you should get that the determinant here is 0. And then for the z matrix, first 2 columns will stay the same. The last column is getting replaced with the constants. And you should get a determinant here of 23. So go ahead, take some time, work those out, and bring your solutions in the class. Once you've worked them out, draw your line for your summary, and that'll be the end of these notes.